Hello everyone, welcome to my YouTube channel. So today I'm going to show you how to design a simply supported beam. So looking at the AutoCAD file, you will notice that our question says provide a UB section to carry the UDL above using Eurocode. And the question says that the GK permanent load is 5.3 kN per meter and our variable load, that's QK, is 7.5 kN per meter. So when you see this kind of question, I will recommend Tekla Tedds for you. So Tekla Tedds is actually one of the best software and fastest software to solve this kind of issue. So I'll go to my Tekla Tedds. When you open your Tekla Tedds, go to New, that's Create New Document. Then you go to your beams, that's steel beams. You choose steel beam analysis and design year 1993 because we're using Eurocode. If you are using BS code, this is your BS code, another code. So I'm using Eurocode. Go to steel beam analysis and design, click on it and click calculate. So calculation sheet will be open with a dialog box. Okay, so come to geometry. Here is where you put your beam span. Don't put length, it's written length, but what you're going to supposed to put there is beam span. So our beam span from the question is 4 meters. So I'm going to put 4,000 millimeters. So okay. Then loading. If you come to loading, we already have software. So material, whatever material you're going to choose, the software will automatically calculate the software. So I'm going to add load. So select UDL, permanent load. Our permanent load from the question is 5.3. I'm going to type in 5.3, then add another load. Select the type of load to variable load. Then our variable load is 7.5. I'm going to add 7.5 kilonewton per meter. So that's the load we have. Then click OK. Then load combination, permanent load 1.35, variable load 1.5. That's Eurocode load factors. Click OK. Then you come to grade of steel. I'm going to use grade 355. Steel grade of 355. Then I'm coming here to select my section. I'm going to select UB section, universal beam section. Then I'm going to start from the smallest beam section. Then if it doesn't work, we'll go to another section, the higher section. So select the smallest, that's UB 127 by 76 by 13. Select it. Then number of sections, just one of it. I've chosen my grade. Then intermediate lateral restraint. If there is no restraint on the side of the beams, you have to put this thing to 0. That's to know. But if there is restraint, you put it to area is being restrained, or if it is fully restrained, put full. But for now, there is no restraint. We assume that the beam is standing on its own. None. Then you see the beam is failing. The bending moment and buckling moment is failing. So I have to choose another section, higher section, that's 152, 89 by 16. Then select. Beam is still failing in deflection and buckling. So I'll go to a higher section again, 175, 102, 19. Select. So the beam is still buckling. Then I have to go back again. Select 203, 102, 23. Select. So the beam passed perfectly. So we have utilization ratio for deflection 0.509. So if you watch this calculation results, our beam pass very well. So you want to display your output, you can click output. What will display in your calculation sheet? Member sketch, beam geometry diagram. So let me leave it by default and click OK. But if you come to this page, there are design options. So we have unfactored load types, included in total deflection. So this area is where you check both the permanent and variable load is depends on the nature of the beam. For example, if it is a house renovation, let me say there is a structure existing on top of the beam. So you want to remove something. Let me say you want to remove a wall in the ground floor, but you need a beam to support the wall on the first floor. So when removing the ground floor, introducing your beam, the beam is carrying a dead weight already. So we have to put permanent load in part of deflection because the beam is experiencing dead weight immediately. But let me just see that what we are designing is a new structure. So I'm going to leave it to variable load for our deflection. So click OK, then finish. This is our calculation sheet. This is our design. Maximum moment, this maximum share, deflection. So let's go through this. So this is section type that is satisfactory. Okay, 203 102 by 23. Our stick grade is S355. So if you're in Nigeria, the steel we mostly use in Nigeria is S275. So if you're in Nigeria, I recommend 275 because that's the steel we mostly find in Nigerian market. Click OK. Still passes. So thank you for watching. See you in my next class.